Thank you very much. Thanks. Talk to you. Okay. We're going to learn about integration with partial fraction decomposition or partial fraction expansion. We're going to deal with the simple ones, and then we're going to deal with the complex ones. I'm just going to show you one simple one, and I'm going to go right to the complex ones, the improper ones. So here, so I'm doing an abridged version of my what do we call it? My lesson. Okay, partial integration partial fraction decomposition. Okay, essentially, if on an AP exam they give you an integral that looks like this, where you get to factor the denominator, and you cannot use U substitution, then this is a great candidate for partial fraction decomposition. Just like, remember those telescoping series, where the only time you could do a telescoping series is if they gave you a summation where the denominator here factored. That was the only type of thing you could do a telescoping series on. Well, the same thing holds for partial fraction decomposition for integrals. You only get to do them on integrands where it's got a denominator that factors. So let's go for it. This is equal to the integral of 1 over x plus 2 times x plus 3 dx. Okay. And now I'm going to do the AB thing. I got 1 over x plus 2 times x plus 3 equals a over x plus 2 plus b over x plus 3. Then I'm going to multiply both sides by the least common denominator. So I get 1 equals a times x plus 3 plus b times x plus 2. Then I'm going to let x equal negative 2. And I end up with a equals 1. And I'm going to let x equal negative 3. And I end up with b equals negative 1. You guys okay with that? By now, I'm hoping many of you are extremely fast at this, because we did it to death, in chapter 9. And so this ends up being the integral of 1 over x plus 2 minus 1 over x plus 3. But now, instead of plugging in all the terms and having the series telescope, I'm just going to take the antiderivative of each of those two individual terms. So this ends up being the log natural of the absolute value of x plus 2 minus the log natural of the absolute value of x plus 3.
And with the log natural ones, can't you say that it's you divide the x plus 2 over x plus 3?
Hey, absolutely. And so if this is a multiple choice test question, or you're looking in the back of the book, they may present the answer like this. Yeah. Cool. So that's it. So the easy versions of this problem, you'll just do like this. And I feel I don't have to give you a practice problem on this. I think this is good enough for you. The only time this becomes interesting is when the degree of the numerator is greater than or equal to the degree of the denominator. What if the degree of the numerator is greater than or equal to, the degree of the numerator is greater than or equal to the degree of the denominator? And the answer is, you can't just do partial fraction decomposition because you don't get the right answer. Let me show you. See, how am I going to do this? Shoot, I had a really good, here, I've got to think for a second. Oh shoot, I'm not going to show that. I think you're just going to have to take my word for it. Okay? Yeah, you're going to have to take my word for it. Oh, I don't know. No, I have this need to show you. Here, just a second. Just a second. I'm so sorry. Wait, this is chapter 8. Shoot. Now that the video is just rolling and rolling, Mr. Shane is just sitting, doing his thing. Sorry. Maybe I don't have it. No, I don't have it. You are just going to have to take my word for it. All right, never mind. Here's the thing. Oh, heck. Okay. I'm sorry. Hello, video. Sorry. I'm just going to tell you, when you have a situation where your fraction is improper, that is the degree of the numerator is greater than or equal to the degree of the denominator, then you must do polynomial division first. You can't just haul off and do partial fraction decomposition, because you'll end up getting an answer that isn't the complete answer. Okay? Like, let me give you an example. And so I'm just going to show you an example and have you do an example. Suppose I have this, the integral of x squared plus 5 over x squared minus 3x plus 2, okay? If I just did partial fraction decomposition, so I'm going to zip through this. So, you know, if I just did partial fraction decomposition on this, then I'd be saying x squared plus 5 over x minus 2 times x minus 1 equaled a over x minus 2 plus b over x minus 1. Alrighty? And so I'd have x squared plus 5 equals a times x minus 1 plus b times x minus 2. And so if I let x equal 1, okay, then I'd have 6 equals negative b, or b equals negative 6. And if I have let x equal 2, then I get 9 equal a. Alrighty? So I would be chopping this guy into 9 over x minus 2 plus or minus 6 over x minus 1. Okay? But the problem is this minus this doesn't actually equal that. Okay? I mean, if I did 9 times x minus 1 minus 6 times x minus 2 over x minus 2 times x minus 1, if I do that, then I don't get that. Alrighty? I get something different. Okay? So the point I'm making is you don't get to do partial fraction decomposition until you've made this a proper fraction. That's kind of all I wanted to tell you about this. You know, because look, I went through the whole process, I did it totally right, and I'm getting something that isn't that. I'm getting 9x, I'm getting 3x minus 9 plus 2, 3x minus 7 over x squared minus 3x plus 2. And I'm going, wait, 3x minus 7 over, that's not the same as this. And the reason is because you have to do polynomial division first. This partial fraction decomposition stuff only works on proper fractions, not improper fractions. So let me now show you the process you're going to have to go through. You can't just haul off and do partial fraction decomposition, or you'll get a wrong answer. So here's the process you want to do. What if blah, 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 like this? The answer is do polynomial division first. do polynomial division first, which means I have to actually do x squared minus 3x plus 2 divided into x squared plus 5. Polynomial division is something you learned about in Algebra 1, unless your teacher didn't teach it to you. And you also learned about it in Algebra 2, unless your teacher didn't teach it to you. Those of you who did remember it, do you remember what I have to put right there between the x squared and the 5?
0x.
Yeah, 0x. Those of you who knew to do that, somewhere in your past you might have been taught this. So next, I asked myself, what times x squared gets me x squared? And you only look at the leading terms. What times x squared gets me x squared? 1, right? So I do 1 times x squared, 1 times negative 3x, 1 times 2. And now, just like normal division, if I divide 5 into 32, you know, you go 6, and so that's 30, and you subtract, right? With normal division, you subtract. You do the same thing here. You got to subtract this. So you got x squared minus x squared, which is 0, 0x minus negative 3x, which is 3x, 5 minus 2, which is 3, okay? And that's it. You're done. You're done. You got 3x plus 3. So you got 1 plus 3x plus 3 over x squared minus 3x plus 2. So now that I've turned this into 1 plus 3x plus 3 over x squared minus 3x plus 2, now I can do my partial fraction decomposition. Because this is a proper fraction, I can go 3x plus 3 over x minus 2 times x minus 1 equals a over x minus 2 plus b over x minus 1. And now I'll find my a and b now. Boy, I wish I hadn't erased that stuff, because remember what I did the first time? That should have come out to be this, and it isn't. So I must have made a mistake somewhere. But oh well. So I got 3x plus 3 equals a times x minus 1 plus b times x minus 2. So I'm going to let x equal 1. And I get 6 equals negative b, or b equals negative 6. Okay, and I let x equal 2. And I end up with 6 plus 3 is 9 equals a. So I don't know if you remember, when I did this before, I ended up with b equaling negative 6 and 9 equaling a. But the difference is I've got that 1 there, where before I didn't. So I was going to get a wrong answer. So this ends up being the integral of 1 plus 9 over x minus 2 minus 6 over x minus 1 dx. Alrighty, and now I can take the antiderivative and I get this extra term. And that's what characterizes partial fraction decomposition when you have an improper fraction. You end up getting these extra terms. So I got x plus the log natural, 9 times the log natural of x minus 2 minus 6 times the log natural of x minus 1 plus c, and that's it. I can't simplify it anymore. So there's your answer. So hey, it's time for you guys to do one. Okay, here we go. The integral of x to the third minus 3x over x squared minus 1. Notice this is improper, so you're going to have to do polynomial division. Please do polynomial division and then carry out partial fraction decomposition, and then we're done. And I'm going to walk around and help you, because I want to make sure you guys are doing the polynomial division correctly. Well, no, you'd go x squared minus 1 into x to the third plus 0x squared minus 3x plus 0. You should get x minus 2x over x squared minus 1. If you're not getting that, you need to call me over so we can see what you're doing wrong with your polydiv, your polynomial division. But that should be what you get. And then you can go ahead and do partial fraction decomposition, or use substitution, actually. But do partial fraction decomposition so you can get the experience. But you can do substitution as well. The key is I need to make sure that you guys can do that polynomial division. Yes?
Can you explain to me one time the polynomial division?
Yeah. You got to ask yourself, what times x squared gets you x to the third? And you know that that's x. And then you do x times x squared, which is x to the third, x times negative 1, which is negative x. Then you subtract it, and you keep going until your remainder is of a degree lower than this. Then you just put that over the divisor.
All right. Thank you.
You're welcome. Anybody else need me to talk more about polydiv, polynomial division? Sorry about that. I need to kick you back. What the heck? But that x to the third should be under the x to the third. It's crazy. You're poly crazy. Polydiv crazy. Yeah. Yeah, there it is. That's all there is to it. How's it going? Good. I'm glad you answered good, because if you said bad, I wouldn't have known what to say. There it is. Anyway, wait, you should do x, because x times x squared gets you x to the third, not 1. So that first term has to be an x, which means now x times x squared, x to the third, x times negative 1 is negative x. And so everything gets shifted over. All right, doing your notes on the back of your notebook. Good for you. Yeah, there you go. How orderly you are. Yeah, there you go. Good. No, that should be a, oh good, that should be a negative 2x. But you got it up there, correct? Yeah, negative 3x plus, negative 3x minus negative x. Yeah, good for you. Yeah, that would get it done. Well, it's weird how it's also, oh yeah, it's log natural x squared minus 1. Yeah, that's good. keep working, but I'll complete this one. Yeah.
It's a negative 2x.
Thank you. Who said that? Who said I distributed it? Was that you, Kimberly? Whoever said it, thank you for backing me up. It was Kimberly. Oh, you lie. Oh, God. Oh, you liar. You know who else lies? Satan. He's the father of lies. Okay, but you guys okay with that? Yeah. Yeah, I don't know. I did this guy and then I kept the minus, but I could have made it negative 2x and then I got -1, -1, and it would have been the same answer. And you'll notice you get the same answer that you would have gotten had you done U substitution. You know, so it's all good. Okay, hey, we got 2 minutes left. Any questions or problems on this process? Then I just want to tell you, on tonight's homework, you're going to get a chance to do lots of problems, and the only thing that's tricky is when you're presented with an improper fraction, you've got to do polynomial division first. That's it. That's the only thing that makes it weird. Once you do the polynomial division, then you go ahead and just carry out your partial fraction decomposition and you know, let it go. Just be like Moana with the Polynesian expansion. Only this isn't Polynesian expansion, this is polynomial division. But it's like the same thing. Okay, we're done. Bye-bye.